But electric arcs aren't the only way to make a weld. In fact, others are a real blast. Pennsylvania's Allegheny Mountains, birthplace of American steel. Here in the hillsides that surround historic mill towns, the most powerful welding process of all occurs, more than half a mile underground.
Fire in the hole!
It's called explosion welding. And with a force measured in millions of pounds per square inch, explosion welding does what no other welding method can. Join nearly every kind of metal together, no matter the type or composition.
Explosion welding allows highly dissimilar metals such as aluminum, carbon steel, alloy steel, stainless steels, alloys of copper, all can be welded to one another.
The result? A single welded piece known as clad that combines the best characteristics of each metal involved. Wherever there is high heat, intense pressure, or corrosive liquids and gases, clad is probably there.
It could be a column, it could be a heat exchanger, it could be a horizontal tank, but when you see a chemical complex or an oil refinery, there'll be a lot of clad metal in there.
To create an explosion weld, two large pieces of metal are stacked atop one another, then covered with a high-powered explosive. When detonated, the downward force of the explosion welds the two pieces together through a combination of intense force and remarkable physics.
What you can see here, and it's very clear, you have two different materials. Stainless steel is a darker gray, a lighter gray for the carbon steel material. The detonation was initiated at this point, and you can see the deformation from our initiator. That starts the explosion, and the explosion rolls across the entire top surface of the plate, zipping the two together.
No one would have ever thought such a violent process could be controlled and mastered had it not been for the devastation and havoc of World War I, and later, World War II.
The origin of explosion welding was first observed during the First World War when shrapnel may have stuck to armament. It wasn't just stuck, but it was actually welded.
There was only one possible explanation: the explosive force these metal pieces had endured.
It was an observed phenomenon that was later duplicated in the laboratories and practiced commercially.
Today, Dynamics Materials Corporation is a world leader in explosion welding technology. Here, the decades-old discoveries from the battlefield have been refined into an exacting science. The explosion welding process begins as soon as the two metal plates arrive at DMC's main plant, outside of Pittsburgh, Pennsylvania. To maximize the welding force of the explosion, the surfaces of each plate are ground as uniformly flat as possible, a process that also removes any rust, oxides, and other surface flaws. They're then ready to be assembled into the pack, which locks the plates into position for the explosion. To build a pack, the stronger and thicker of the two plates is laid face up. From now on, this plate will be identified as the backer. Small metal spacers of equal height are then tacked onto the surface of the backer in a uniform grid. These spacers will maintain a set gap between the backer and the second plate, which is placed on top. This second plate is thinner than the backer and is called the cladder. The standoff gap between the backer and cladder is less than an inch in height. Yet without it, the explosion weld would be impossible. In the final stage of assembling the pack, a folding wooden frame is constructed along the edges of the cladder. When this frame is later unfolded inside the underground explosion chamber, it serves as the bed for the explosive powder that is poured on top.
The three essential variables of an explosion weld are, first, the standoff gap, the spacing between the two metals needs to be very tightly controlled to ensure the highest quality weld. The second two parameters deal with the explosive. One is the velocity of the explosive, the speed at which it burns, and the height of the bed or the quantity of explosive which is evenly spread on the top plate.
The explosive powder is a proprietary blend of common and unique explosive chemicals. The amount and exact formulation is always matched to the types of metal involved. Once the pack is set, everyone evacuates the chamber except the blaster in charge, who remains to wire the detonator. He will be the last to leave the chamber. After all personnel are accounted for, the blaster connects his initiator switch to the detonator wires and fires the explosion.
Fire no!
The explosion is detonated from one edge of the cladder and moves across the upper level of the pack at a uniform speed. This explosive front progressively drives the cladder plate downward toward the backer at the slight collision angle caused by the standoff gap. Forward of the collision point, air is forced out of the gap at high velocity. All oxides and impurities are expelled, rendering the plate surfaces metallurgically pure and ideal for a weld. As the backer and cladder collide, the weld is created nearly instantaneously across the entire surface of the plate. Because of the intense dust created by the explosion, workers can't retrieve the newly formed clad from the explosion chamber for more than 18 hours. Not surprisingly, the power of the explosion can cause significant deformation to the newly formed clad. Therefore, upon its return to DMC's central processing facility, the clad undergoes a final series of corrections. These include heating the clad in an oven that causes the metals to soften slightly. This relieves stress from the blunt force of the explosion's impact. Any bowing or misshapen curves are flattened out by either a 3 million pound press or, for thinner clad, by a series of rollers known as levelers. Finally, before the material is shipped, stringent testing is conducted to ensure a solid weld between the two plates.
There's a lot of testing because generally these metals will go into a very high pressure vessel. The stakes are extremely high if there's a failure. So the owners of big plants in chemical manufacturing and oil refineries are extremely concerned that their materials are what they ordered and specified. There's really no room for error.
Once the material has been proven to meet exacting specs, it's ready to be shipped to the customer.